Okay, so I've got this sandblasting slash vapor blasting cabinet, and it uses these ceramic nozzles. Anybody who's sandblasted is familiar with these, and you can see what's happened. This one is long since worn out, no longer round. The cone is all but gone on the back side. And you can buy and replace these, and they're not expensive. These are pretty cheap, but they do wear out faster than some of the other ones, like the boron nitride and some of the other tool steel and a few other nozzles. But suffice it to say, grinding, which is what sandblasting is one of the most abrasive things that you can do. It's the reason that we use surface grinders to grind hardened parts to dimension. We just can't cut them on the mill. They need to be done on the grinder once they've been hardened. So ceramic is extremely hard, much harder than even those hard steels that we grind, but it still can wear. So I was thinking there's two approaches to this. All right, I can order these, sure, no big deal. But I really thought about the manufacturer. Sorry, I just lost my light here. I apologize for that. About the manufacturing process of these devices and some comparable theories, right? A lot of times harder is better for things like this, but sometimes soft is very good. If you've ever hit anything rubber with a sandblaster, you know it has almost no effect on it. You can sandblast over masking tape. And a light blast just ignores the masking tape. It absorbs the blow instead of being etched off the material. So they got me thinking, one of the most durable materials out there is UHMW, ultra high molecular weight polyethylene. Okay? It's used in skid plates. It's on a bunch of my off-road equipment. It's used in slide maneuvers. It has almost the same lubricity as Teflon. It's extremely slick stuff. So I've got a ton of this UHMW lying around, and my thought is, I own a machine shop, right? So why not try making a nozzle out of just material that I have laying around? So my thinking is this: with how slick this is and how little damage taking, say, like a flap wheel to it does to shape this stuff, it's harder to shape than steel is. From a flap wheel, it cuts extremely well on the lathe. It's a nice sharp tool. On the mill, over here, as we'll see, I was going to go lathe for one, mill for the other, but decided to do it all on the mill here. So this UHMW, we're going to go make a nozzle. So let me get reset up and get my lighting fixed again so you don't have shadows on half the shot. And I'll come back with the setup and show you what we're going to do to make one of these out of this. Okay, so here we are. We've got our material clamped into the mill here. And what I'm going to use to cut out the slug is an annular cutter that coincidentally has the exact same inner dimensions as the outer dimension of the ceramic nozzle. So what we're going to do is, this will be the last operation really, is we're going to come over first and drill a pilot hole where this is going to follow through, but that'll also be the media hole that gets used when the blaster is running. So I just want to be sure that I've got enough material here on my, my UHMW. This stuff is notoriously hard to mark on because of its lubricity. But I'll put a little mark and make sure, just double check. Okay, good. It doesn't matter that we're going outside a little bit. This is going to be the last maneuver that's going to cut that free. So we're good there. And what we're going to do is we're going to drill that center hole, like I said. And I have a smaller air compressor than this original sandblaster was made for. So instead of this larger diameter, you can see what it, or closely see what it might have been in the beginning, probably 3/8 of an inch or so. I'm going to go down to a 1/4 inch. And my blast cabinet, I'll do a review of this. It's a Vaporblast. So when you're using water and air together, you actually can get away with more than just air because water is not compressible, et cetera, et cetera. I'll cover that in another video one day. But suffice to say, we're going to drill the center hole, then we're going to create the taper, and then we're going to cut this out and cut it to length to use as our blast nozzle. So let's go ahead and get the center hole drilled here. I do have to say, I absolutely love working with UHMW. I really do. Plastics are great, but the lubricity of this stuff, it just machines beautifully. So let's go ahead and get over. Okay. And check here. We're a little behind, but that's okay. That just makes sure that I don't break through the wall with my annular cutter. All right, lock our table in place. And even though we're not doing a lot of repeated operations, I like to zero everything on my DRO, just in case I should have to come back to a setting. All right, so let's go ahead and drill our center hole. And what I'm going to do is I'm actually leaving a small amount of material on the bottom intentionally. When the annular cutter goes in, the center plunger pushes the slug out. If I were to drill all the way through, what would then happen is this block of UHMW would become stuck up inside the annular cutter and it'd be quite difficult to remove. So let me go ahead and grab the nozzle here and we'll show you that depth-wise we're about here. So we can look and see, I didn't mark this, but you see we're already past our nozzle depth, but we haven't gone completely through the UHMW, so we're in a good spot. Okay. Great thing about this is none of this is critical dimensioning. So we're gonna go ahead and get the drill bit out of here and then remove the chuck, put in our annular cutter, and go ahead and cut the slug in a minute. But before that, this is really cool. I have, of course, my countersink, which happens to fit perfectly that nozzle. So you can see we're a little bit high there. So I'm going to go down and grab the next size countersink and take a look at that one. So what this is going to do is it's going to allow me to do that conical jet inside. And as soon as the bevel on the countersink reaches the top edge of the material, I'll know that I have the correct bevel inside. Okay. Get our countersink in. This is all an experiment, by the way. I haven't found anything on YouTube about people actually doing this. I've seen a few comments of people considering trying it, but I haven't found anybody who's actually done it. So we'll see what happens. We're going to test this in the blast cabinet, and maybe I'll do that as part of the blast cabinet review, combine the two videos or something. I haven't got a clue how I'll handle that yet, but we'll cross that bridge when we get to it. Okay. So we've got our bevel cut. We have our blast orifice cut. What we got to do is change this out now and get in our annular cutter, and we're ready to cut our nozzle out and then cut it to length. Okay, I've got to bring the table down to get the annular cutter in. There we go. There, we've got our annular cutter in. We'll come back up. Here we go, and cut out our slug. I want to get all this stuff off of here so it doesn't begin to melt as the cutter warms up. There we go. Stuff sure is stringy. We have to use nearly the full length of the annular cutter to get through this UHMW. I wanted to be sure that I had A, enough length inside the cutter to make the slug that I needed, and B, enough material down here to hold everything in place. So we need pretty much the full depth of the cutter, so I have to make sure I can get those strings off of there so I can go all the way through. There we go. Broken through. And our slug is still up in there, which isn't that big of a deal. A couple taps usually bring something like that loose in an annular cutter. But because we've got plastic, it can deform a little more than a more rigid material, and can actually get stuck in the cutter sometimes. So all I'm going to do is take this over the bench, take the cutter off, and push that slug out. So that'll be no big deal. But I'll be right back after I do that, and we'll take a look at our slug. All right, here we go with our slug removed. You'll notice there is a little bit of flash left on the bottom. That's by design for an annular cutter. What they're designed to do is leave very clean holes in the material being cut. So they are designed to leave the remnants attached to the slug that gets pushed out. So you can see we've got our hole down in there. We've got our bevel. I'm not sure how well white is going to show up on camera here. We'll go ahead and do that. What we're going to do is we're going to turn it over in a V-block and just deck it off to the same height as our nozzle. So let me go ahead and get that set up, and we'll be right back. Our material's held in the V-block with the sealed end out the nozzle. The taper is on the bottom. And I've got it above a small parallel, not even parallel, just a piece of scrap, to be honest. But all that's for is so I can align the two heights of the original nozzle and the new one. And we're going to bring in the fly cutter and fly cut this. So let's go ahead and get this centered underneath the fly cutter. There we go. Bring this over so I can set my height. And we're going to do tiny little cuts. This isn't held very rigid in here right now because A, it's hollow and I don't want to crush it. So I had to basically hold it lightly, you know, and we obviously want to use the fly cutter. That's big amounts we're going to be taking off. Now these measurements aren't 100% critical either. That this height here, the nozzle's held in by a screw cap. I'll show that when we go put it back on. So if the height is off by a little bit, it's not really going to matter that much. But I do want to make sure that we don't take off more than we need to. I'm just getting my stop set up on the top of the mill here. So now we have a positive depth stop. And we can begin our fly cutting operation. Where are we at? RPM wise. There we go. Go nice and slow. Okay, we can come down a little more. Really just wanted to get my initial cut set so then I can measure my next cuts. Here we go. And again, you can cut this material so much faster, but because of the precarious hold in the machine, I just want to go nice and slow and let it take little chips and small cuts. There we go. And I'm really only going about probably between a 1/16 and an 1/8 of an inch each time. I'm just whittling my way down. Okay. You can see how beautifully this stuff machines though. It leaves such a beautiful finish. I like working with it. The white is okay. When you get to work with the black, the darker colors, you really can see the surface finish show beautifully in those. Comes out almost like a machine and polished aluminum combination. If you haven't tried this stuff for prototyping and small things, I really suggest it. It's great to work with. I just absolutely love it. All right, we can see our hole starting to appear. We're actually almost down to depth now. A couple more passes. Should just be one more pass. We'll take this one a bit chunkier, risk it. Just crank it nice and slow. Once we're getting lower to the vise, I have a little more confidence in taking a little bit bigger cut, less stick out that we're actually machining. So. There we go, one UHMW sandblasting nozzle. Get this out of here and take a look. Okay, here's the original nozzle. All right, and here's our UHMW counterpart. You can see we got our taper in here. We have our orifice, same diameter, and same height. So we'll go ahead and put these in the blasting machine and see how this goes. Okay, here we are in the blasting cabinet, and here's the blasting gun, and the original nozzle just fit in like this. and there's a retaining ring that goes over the top. You see it's nothing fancy, just a plain old everyday blasting gun. So nozzle goes in. All right, we'll grab the new nozzle that we just made. We'll put this one in. And we'll get the retaining ring. And as I was stating earlier, the length of the nozzle wasn't critical because of the design of this ring. You can see it just holds the nozzle in place, and we have a lot of thread. So, being off by a little bit wasn't going to change anything. Okay, you can see there's sand all over the walls here. I have a scrap piece of material I was testing with, and I've converted this from a dry cabinet to a Vaporblast. So it actually has water and media slurry that it jets out, as well as the air pressure that a normal sandblaster would have. So I'm going to go and get on the window over here and see if I can show you guys this unit in action. I'm not sure if I can get a good angle with the camera, but we'll try. Okay, this is going to be a little sketchy to do one-handed. As you see, I don't have anything in my cabinet right here holding the parts up. It's just the crossbars. I'm reworking some of the inside of the cabinet at the same time that I'm doing the vapor conversion here. This was originally a dry blast cabinet. So let's go ahead and see. We're going to get our slurry going. Upon first startup, it takes a little bit to get the slurry going. Yeah, our slurry down here has to stir quite well before we get an even spray out of here. I can see I'm getting material removal, but not at a very good rate. I don't think the camera is going to pick this up at all. No, we're getting too much air, not enough water. It's clearly telling me that our nozzle is too small and I need to drill that hole out larger. So I'm going to do that and come back with it and see what we end up with. Okay, so here we are back in the cabinet, and I had started up with a 1/4-inch hole. We're now at 11/32. I'm having the gut feeling I might need to sneak up on 3/8, but let's go ahead and try this here. What I wanted to show was the, this is just the slurry at the moment. There we go. As the slurry gets going, you can see that nice big jet of material that we have coming out. There's no air pressure behind that. That was significantly more material than we had previously with the 1/4-inch. Obviously more can get through. But we're going to go ahead and put the air back on. And one of the ways you can tell if you have too much air and not enough slurry mix is your cabinet gets extremely foggy inside because the air is just atomizing the little bit of water that's coming through. All right, so let me go ahead and turn the air back on, and we'll come back and do this with the air on and see how we're doing. Okay, we got the air back on. This is likely going to get a lot louder. The compressor is going to kick on, all that kind of good stuff, but let's see how we're doing. Okay, we can see that there's a lot less fog, but still very little fluid coming out. And we can see down here very little draining out of the cabinet. I bet I'm going to need a larger nozzle. But the blasting performance is amazing. Wow. I might leave that way. Wow, this nozzle is doing great. Since these are so easy to make, I might go ahead and make another couple. I might drill this one out larger and try the 3/8 and see how it's doing. But that blast performance is far superior to the ceramic nozzle that I had in there earlier. That's amazing. What I'll do is I'll get a few pieces of material in here and show you the difference between the old nozzle and the new one, side by side. Okay, so here we are in the cabinet. You can see we've opened that up to 3/8 of an inch now. Originally it was a 1/4, then 11/32. Now we're going to go 3/8 and see how we do. Not that we blasted much, but there's zero sign of wear on this side. Put that in, get our retaining ring in. Maybe, come on. A little gritty. There we go. Lock everything back up. Okay, and let's see how we do now. Okay, definitely less fog, still a lot of fog creation, but I can still see what I'm doing. It's removing the paint extremely well. I'm not sure if you can see that through here or not. I don't have a window wash unit in here yet. Let's go ahead and try some rust over here. That looks extremely well from here. Let's look inside the cabinet and see. Okay, still a little foggy, but considerable rust removal. The previous nozzle was doing nothing right here. That's great. It was barely even taking the paint off, and you can see it stripped it right down to metal very quickly. Same thing for down here. Got our rust pits and some metal, but it stripped that off extremely fast. I'm very happy with this nozzle. I'm going to give it a long-term torture test and probably just blast a few pieces, just really to see how the nozzle's gonna last. I'm not sure the blasting capacity between the smaller orifice and the larger, but this seems to be doing a great job. All right, thanks. So far, it's a success. I'll do another reviewing the nozzle after it's had some more time.